Hello everyone, a very good morning to all. I hope you all are doing good and safe by the grace of God. Students, we have successfully completed 3 units, right? Now, let's start a new unit with the coach of Mendeleev. If all the elements are arranged in the order of their atomic weights, a periodic repetition of properties is obtained. This is expressed by the law of periodicity. Hope you would have guessed the topic. So, let's start Unit 3. So, in today's class, we are going to study Unit 3, which is periodic classification of elements. So, the first question comes to our mind is what is periodic table, right? So, the periodic table is nothing but it is a tabular display of chemical elements and they are organized based on their atomic numbers, electronic configuration, and chemical properties. There are about 118 elements have been known to us till today. Based on their properties, all the elements are arranged in order known as periodic table. I hope you would have learned about this lesson in your lower classes. Right. Now, let's see the introduction. These are millions of chemical compounds existing in nature with different composition and properties formed from less than 100 naturally occurring elements. The discovery of elements is linked with human civilization. Over the years, more and more elements were discovered. In 1789, Lavoisier, that means Anthony Lavoisier from France, published the first list of chemical elements containing 23 elements after several experimental investigation. He classified the substances into 4 groups elements, namely acid making elements, gas like elements, metallic elements, earthy elements. Now let's look at the table for these 4 groups of elements. This is the table for acid making element and gas like element. So acid making element is sulfur, phosphorus, charcoal or carbon, etc. And then for and this is for metallic elements and earthy elements. Let's move on to the next one.
Students, do you all know the history of periodic table and how this periodic table came? I'll tell you. The first thing happened in 1789. Anthony Lavoisier published a list of 33 chemical elements, grouping them into gases, metals, nonmetals, and earth. And then in 1829, Dobrynin observed that many of elements could be grouped into triads based on their chemical properties. Then in 1866, John Newlands arranged elements in order of increasing atomic masses, and he found that every eighth element had properties similar to that of first. Then, in 1869, Mendeleev arranged on the basis of their fundamental property and he discovered 63 elements. These are the history of periodic table.
Classification of elements. You have already studied about elements, right? So, what is elements? An element is a substance that cannot be broken down into any other substance. Every element is made up of its own type of atom. This is why the chemical elements are all very different from each other. Then everything in the universe contains the atoms of at least one or more elements. During 19th century, scientists have isolated several elements and the list of known elements increased. Currently, we have 118 known elements. Out of 118 elements, 92 elements with atomic numbers 1 to 92 are found in nature. Scientists have found out that there are some similarities in properties among certain elements. However, the classification is based on the atomic weights lead to the construction of the proper form of periodic table. Now, let's see the reason for a classification of elements. So, these are the reason. Study elements in an organized manner. We should study the elements in an organized manner and we have to correlate the properties of elements with the other. And then a relationship between one element with another. Next, we move on to the Dobrynin traits. Doberiner traits. Johann Wolfgang Doberiner was a German chemist who tried to arrange the elements with similar properties into groups. He also identifies some groups and each groups had three elements. So he named these groups as triads. Doberiner states that when three elements of the triads were arranged in the increasing order of their atomic masses, the atomic mass of the middle element is nearly the same as the average of atomic masses of other two elements. So, this observation was the basis of his classification and then on elements into what is called as Doberiner traits. We all know that he made many efforts, but he could find only just three traits with similar properties which follow the atomic mass. Students, look at this table. So here it has given first triad, second triad and third triad. So the first group had lithium, sodium and potassium. Lithium has atomic mass of 7, sodium has atomic mass of 23 and potassium has atomic mass of 39. If we find out the average or the arithmetic mean of the first and the third element, that is lithium and potassium, we will find it is 23, which is the atomic mass of sodium. Such kind of classification works for the first group and the two other groups. One add chlorine, bromine, iodine, and the other add calcium, strontium, and barium. But this situation did not remain the same as he proceeded further to classify the other elements. As a result of classification of elements into types was rejected. There were three main reasons for the rejection. Let's see what are they. Drawbacks of Doberiner traits. First one is he could only identify three traits out of all the elements known at that time. That is nine elements. Total of nine elements only. The second one is, however, the total number of elements were more than that of those encompassed in Doberiner traits. Thus, Doberiner could not be classified most of the elements known at that time. So, these are the drawbacks for Doberiner traits. Let's move on to the next topic. That is Newland law of octaves. John Newland followed the order of increasing atomic masses to arrange the elements. In 1964 to 65, he noticed that by arranging the known elements into atomic weight order means elements with similar properties recurred at regular intervals. The arrangements of every eighth element had the properties similar to that of the first. For example, properties of lithium, sodium were found to be the same. Newland proposed a law states that the properties of the elements are a periodic function of their atomic weights. And it is by drawing an analog with music. His law is known as the law of octaves. Newland also compared it with the octaves that found in music. Look at this table. In the Indian music, we know the seven musical notes, right? What are they? Sa, Re, Ga, Ma, Pa, Da, Ni. And however, in the West, the musical notes are do, re, mi, fa, so, la, ti. Further, in order to fit some elements into his table, Newland put two elements in the same cell. What are they? Look at here. Cobalt and nickel is kept in the same cell. But this technique did not work as they have different properties. So it does not work. However, the law of octet had limitations as it was applicable up to calcium only. And after calcium, every eighth element had no similar properties to that of the first one. So This is the Newland law of octaves. Let's move on to the next one. Students, do you all know his name? So, this is the Newland law of octaves. Let's move on to the next one. Students, do you all know the name of the scientist? Yes, his name is Dmitry Mendeleev. He was a Russian chemist and inventor. So, now we are going to see about the Mendeleev's periodic table. What did Mendeleev do for the periodic table? Anyone knows? I'll tell you. He arranged the elements in order of increasing relative atomic mass and he discovered 63 elements. Then, in the year 1868, two scientists, one is a German scientist, another one is Russian scientist, they worked independently and they came up with the identical classification of elements. Here, the Lothar Meyer, a German scientist, and Mendeleev, a Russian scientist, they both worked on periodic properties of elements with their atomic masses. But what is the difference between them? Let's see. Here, Lothar Meyer only focused on physical properties and Mendeleev has completely focused on chemical properties. Then Lothar Meyer named it as Lothar Meyer atomic curve and he named it as Mendeleev periodic table. Mendeleev periodic law states that the properties, which is the physical as well as the chemical properties of all elements, are the periodic functions of their atomic masses. And then atomic weight and chemical reactivity are the two parameters he chose for classifying the elements. Then Mendeleev listed 70 elements which were known to us this time in several vertical columns in order of increasing atomic weight. This Mendeleev constructed the first periodic table based on the periodic law. Let's have a look at this table. This is the periodic table based on Mendeleev's periodic law. In this table, he left some blank spaces since there were no known elements with the appropriate properties at that time. He and other predicted the physical and chemical properties of the missing elements. Then Mendeleev named the undiscovered elements using the Sanskrit word eka, meaning one as a prefix with the name of the preceding element in the same group. For example, gallium was not discovered in Mendeleev's time. Therefore, he left a gap for it in his periodic table and named it as eka aluminium. He also predicted the properties of these undiscovered elements based on their position in the periodic table. A comparison of the properties of gallium as predicted by Mendeleev. Then Mendeleev referred the predicted element as eka aluminium and eka silicon. Now, let's have a look at this table. So here it has given property, that is atomic weight, density, melting point, formula of oxide, a formula of chloride. So eka aluminium is predicted and gallium is observed, eka silicon is predicted and germanium is observed. Let's move on to the limitations of Mendeleev's periodic table. So these are the limitations. Mendeleev periodic table failed to explain the position of hydrogen. It was not able to explain the position of isotopes. You know what are the isotopes? Protium, deuterium, and tritium. In the table, in the periodic table, some elements having a higher mass were kept before the elements having lesser atomic mass. So these are the limitations of Mendeleev's periodic table.
Okay, students, in today's class, what we have learned? we have learnt a new lesson, that is periodic classification of elements. Under that, we have learnt introduction about periodic classification of elements and what is classification of elements. Then Dobrynin's traits, Newland's law of octaves, and finally we have learnt Mendeleev's periodic table and its limitations.
Okay, students, I hope you would have understood the concept of today's class. Go through the lesson, study well, and get good marks. Let's meet in the next class. Thank you, children.